With so much failure found from relativity, how has this theory been introduced in textbooks to students? To start, equation set 1a to d is normally found in textbooks with all a's to remain as unknowns. With many additional conditions, equation set 1a to d finally boils down to set 2a to d, with 3 unknowns, but only 2 relevant equations. This set is unsolvable. To overcome the difficulties, the textbooks introduce equations about light propagation as shown in equation set 3a to b. Given that y prime equals y and z prime equals z are redundant, the textbooks come to an equation set that is shown as 5a to d. So equation set 5a to d now is conditioned to be solved in the following way. No matter how time develops, the observer riding with either the x-axis or x-prime axis must see the origin of one's own frame and the center of the light sphere coincide forever. So when the observer looking at the x-prime axis, he should find that light and the x-prime axis both move in the same direction, pointing toward the positive end on his own x-axis. Looking toward the negative end, however, he would see that the light wave front and the x-prime axis move in opposite direction between each other. How would relativity guide the observer to calculate the distance change in situations like this? Here is a quoted paragraph that is following the aforementioned quotation. Let a ray of light depart from A at the time ta. Let it be reflected at B at the time tb, and reach A again at the time ta prime. Taking into consideration the principle of the constancy of the velocity of light, we find the equation number 6 and equation number 7, where RAB denotes the length of the moving rod measured in the stationary system. All this must guide the observer on the x-axis to obtain the following calculation. For the light front that moves in the same direction as the x-prime axis, he will obtain a distance r plus, so that the traveling time for the light to complete r plus is as shown in equation number 8. For the movement in the opposite direction, he will obtain a distance r minus, and the corresponding traveling time for the light is as shown by equation number 9. Subsequently, this observer must come to equation number 11. To the observer on x prime, the speed of his own frame, x prime, is v equals 0 with respect to himself. With the center of the light sphere and the origin of his own frame coincide forever, he must see r prime minus equals r prime plus equals ct prime, where t prime is quoted from a clock attached to his x prime axis. If the concept of length contraction must play a role in the view of the observer of x-axis, the same contraction multiplication coefficient must be equally applied to the measurement of r plus and r minus, leaving the ratio of r plus over r minus unchanged equals 1. Therefore, the introduction of equation set 3a and b just forces an implicit condition for equation set 1a to d to be solved with v equals 0. With v equals 0, the speed of light c must be 0. Should the students continue to be led by a theory so self-defeated?